Hello. Today, we will discuss perfect conductor and perfect diamagnetism. When examining a summary table of superconducting properties, one can ascertain the overall characteristics of superconductivity. Through today's session, we will gain an understanding of one of the properties of superconductors, perfect diamagnetism, and the Meissner effect. First, let me explain the phenomenon of superconductivity. Superconductivity is the phenomenon where, under specific conditions and in certain materials, electrical resistance disappears and the magnetic field within the material is expelled outward. Let's illustrate this through the animation below. The most crucial condition for the occurrence of superconductivity is temperature. At room temperature, 300 K, which is relatively high, the material exhibits non-zero resistance, and the internal magnetic field is not zero. Therefore, if a current is passed through the material, there will be heat loss corresponding to I²R. However, as the temperature decreases below the critical temperature Tc, where superconductivity begins to manifest, the material's resistance becomes zero, and the internal magnetic field also becomes zero. Now, even if a current is passed through the material, there will be no heat loss. While the graph depicting the magnetic field when it's zero inside is not entirely accurate, we can derive the precise graph by solving the equation. Based on the preceding information, two concepts emerge: perfect conductor and perfect diamagnetism. Perfect conductor can be expressed mathematically as R equals 0 within the material, and dB of dt equals 0 according to Faraday's law. Perfect diamagnetism can be represented as B equals 0 within the material. By changing the temperature and external magnetic field, we can easily explain the two concepts through a series of steps. Starting from state A, at temperatures higher than Tc and in the absence of an external magnetic field, as depicted in the diagram below, no magnetic phenomena occur. Next, while maintaining the temperature as at state B, an external magnetic field is applied. At this point, perfect conductor and perfect diamagnetism do not manifest, resulting in internal and external magnetic fields exhibiting identical phenomena. Next, while maintaining the external magnetic field, we lower the temperature below Tc. This leads to the manifestation of perfect conductor and perfect diamagnetism. Perfect conductor maintains an internal magnetic field identical to the external one, as no change in internal magnetic field is allowed. However, perfect diamagnetism requires the internal magnetic field to remain zero, causing the magnetic field to be expelled from the material. Finally, while maintaining the temperature below Tc, we remove the external magnetic field. In the case of perfect conductor, the internal magnetic field retains the same value as the external field previously applied, resulting in the formation of an internal magnetic field, as shown in the diagram. However, for perfect diamagnetism, regardless of the external magnetic field, the internal magnetic field must be zero, leading to the disappearance of the magnetic field, as depicted in the diagram below. If we revisit point C in the process we just discussed, we can clearly see the difference between the two concepts. These two concepts are distinctly different, and perfect diamagnetism is a phenomenon unique to superconductivity. Additionally, the Meissner effect refers to the manifestation of perfect diamagnetism in superconductors. It's worth noting that the Meissner effect cannot be explained solely by Maxwell's equations, and the precise equations will be explained in Chapter 1.1.4 of the lecture. In summary, superconductivity, type 1, is characterized by zero electrical resistance and the expulsion of magnetic fields within the material under specific conditions. A perfect conductor exhibits an electrical resistance of zero, while perfect diamagnetism indicates the absence of an internal magnetic field. An ideal superconductor demonstrates perfect diamagnetism. The Meissner effect exemplifies the phenomenon of perfect diamagnetism observed in superconductivity. With this, I conclude the presentation on perfect conductor and perfect diamagnetism, Meissner effect. Thank you for your attention.